Hi everyone and welcome to the channel. I go by name Miss B and today I'm gonna do question 10 from 2017 SAYS exam paper. If you do want to stop the video and read instructions for yourself, you may do that. So let's have a look what is given. So the quality of sheep's wool is primarily based on the average diameter of its fibers measured in microns. A wool producer wishes to make a claim about the average diameter. So make a claim about the average diameter of fibers on one bale of wool sourced from one flock of Australian merino sheep. Historically, the wool sourced from this flock has a fiber diameter that's normally distributed. So normally distributed. Standard deviation is equal to 2.5. So the wool producer chooses 80 fibers, so sample size 80, then measure the diameter of each of these fibers and calculate their sample mean. So sample mean is equal to 17.4. So all this is given. Now based on this sample, calculate the 95% confidence interval for the population mean. Maybe you have seen more of a 95% confidence interval, so but pay attention, in this case is 99% confidence interval. So you would have to either know what is the Z value for this or you can calculate. So I'm just going to go quickly how to calculate. So if you go to stat on your calculators, and I'm using Casio CG20 AU statistics, so then distribution, and the next one normal, and inverse, and now you should have a screen when it does ask about data. Make sure you use variable for this. Then tail central area in our case is 99%, so the area is going to be 0.99, standard deviation 2.5, and the mean is, what do we have for mean? 9. Standard deviation is 1 and mean is 0. So the Z is always 0 and 1. So mean is 1, standard deviation, mean is 0, standard deviation is equal to 1. Execute and it's going to give you the Z value for 99% confidence interval, which is 2.58. So you can calculate this for any confidence interval. So question has 2 marks. What I would do, I would substitute the values, so X bar first, which is 17.4, then take away the value of Z, 2.58, times standard deviation 2.5 over square root of sample size 80, less than or equal to mean, less than or equal to right hand side. So it's okay if we have less than or equal to, as it's continuous random variables, so it's not going to make any difference. And then on the other side we do the same, but plus 2.58 times standard deviation over square root of 80. Now if you calculate this, it should give you the answer 18.1 as the upper bound and 16.7. Now I have seen kids calculating this part here, putting on the graphics calculator, and sometimes maybe getting not correct answer. So you can do this. I would still have the first line here, I would still have this line, substitute just in case that this part here it's not correct, so that you can get at least one mark. So how you can calculate this on the graphics calculator, again you go to statistics, then interval, interval, and then you press Z, then one sample, and then you're gonna see the screen again. Data, make sure it's variable. C level, confidence level, you just write what confidence you're using. In this case, 0.99, 99%. Standard deviation is equal to, now it's not equal to 1. Where's our standard deviation? Here, standard deviation there, 2.5. Then X bar, sample mean 17.4, sample size 80, and you should get the lower bound 16.7 and the upper one 18.1. Pay attention to how many decimal places or significant figures you have to have. So let's have a look at the next one. Based on this sample, the 95% confidence interval 16.9, 17.9. So looking at this one here, we can see that 99 confidence interval, it's wider than the 95% confidence interval. So explain why, when based on the same sample, 95% confidence interval is wider than 90% confidence interval. So 95% confidence interval is bigger than 90% confidence interval. So to be more sure of containing mean, okay, containing, my pen, what is going on? Okay, I'm just going to explain this. To be more sure of containing mean, we need to have wider net. So therefore, we're gonna have wider confidence interval. So wider interval is gonna be required. Okay, let's go to next part of the question. Now, based on this sample, the wool producer labels this bale of wool as having an average fiber diameter of 18. So now average, 18. A manufacturer can make a claim with K percent level of confidence if it's supported by K percent confidence interval. With reference to your answers to part A and then the information provided in part B, what can you conclude about the confidence with which the wool producer can label this bale of wool as having an average of fiber of 18 microns or less? Justify your answer. So I like to see the picture. So what I'm going to do, I'm going to have a look at part A. So the minimum was 16, I guess I need pen, 16.7, and the maximum was 18.1. So just going to have that. So yeah. So and this one here was from here to there, 99% confidence. Okay, now let's have a look at part B. What do we have in part B? So the lower one, let me have a look, 16.9. So let's say it's somewhere here, so not to scale, please. So and the upper one is, what is it, 17.9. Please just know it is not to scale. 17.9, and this one here is 16.9. So looking at those two, okay, this one, this interval is, what did I say, 95% confidence interval. Now we can see that 18, okay, 18 lies within 99 confidence interval. So it can't be 99 because obviously, it could be bigger than 18. So we want to claim on average, it's less, than 18. So definitely it can't be 99 confidence interval. So 5 confidence interval. So the upper value is 17.9. So 18 is just outside the 95% confidence interval. So, and this confidence interval can be claimed because now we are certain that it's going to lie below 18, so the diameter is less than 18 microns. So hopefully this makes sense. So part D. So what is the maximum level of confidence with which the wool producer can label this bale of wool as having an average fiber diameter of 17.5 microns or less? So I have seen many kids doing this question by trial and error, which is really great. So if you're gonna go with trial and error, so you do have X bar 17.4 sample mean, standard deviation of the sample mean 2.5 over square root of 80 by trial and error. So using the trial and error, you are trying to find the different confidence interval for different values of K. So, and what you're looking for, confidence interval that doesn't contain, does not contain 17.4. So by calculating this, you may find 28%. So it's going to be 17.2998. I'm going to have a few more decimal places, 17.5002. So this is one of the questions where we should have more decimal places. You're going to see now, whoopsies. So you're going to see now y, 4965, and then 17.3035. This is for 27%. So this one. Now, if we had lists decimal places, so we can just say 17.5 and 70.5. So we do have, you know, both confidence interval would include 17.5. So looking at this one here, so we can see that 28% still contains 17.5, where 27 doesn't contain 17.5. So therefore, we're gonna choose 27% confidence interval. Now, there's other way of doing it. So you're looking, you know, to identify the maximum error. So what we're looking for, it's an average fiber diameter 17.5, and the population sample mean is 17.4. So we do have maximum error of 0.1. So now we can use this value and find Z. So Z times 2.5, and then you just, you know, use all these values and rearrange a little bit, and Z should be equal approximately to 0.358, depends how many decimal or significant figures you're going to use. Now you have Z given, calculated. If you use NCD, so of the matching proportions, so you can find that K is, you know, between 27 and 28. So, and you need evidence to decide that is equal to 27% maximum. Okay, let's have a look. No, that's it for this question. Okay, thanks for watching and see you next time. Bye.